Okay, so we're in a unit on proportions, and we're going to talk about first sampling distributions for proportions. Okay, so here's the situation. You have a population. Okay, the population is size big N. Don't know how big that population is, right? Um, you know that of that population, some p, little p, is the proportion of the population that has a certain characteristic. Okay, don't know what that is, but you know that p% of that population have that characteristic. So you're going to take a sample. Okay, the sample is going to be sized little n, and when you take that sample, you find that the proportion of the sample that has that characteristic is what we're going to call p hat. Okay, now if 1, the size of the sample is less than or equal to 10% of the size of the population, that's going to be like the first thing. Okay, then we're going to be able to get an accurate standard deviation for the sample distribution, right? And 2, if p times 1, or p, now let's make it np, there we go, np is greater than or equal to 10, and n times p minus 1 is greater than or equal to 10, then this distribution is also going to be approximately normal. Okay, and what we're going to find is that the mean of these samples, so like if I keep taking samples over and over and over again, I'm going to get a whole bunch of different p hats. The average of those p hats should be p. Okay, so if I do that, that's great. This means that I am an unbiased estimator, which is awesome. And then if I meet condition number 1, then the standard deviation of the sample proportions, is going to be the square root of p times 1 minus p over the sample size. Okay? And if I meet condition number 2, I'm going to get that mean, I'm going to get that proportion, and it will be approximately normal. We call this the 10% criteria. We call this one the large counts criteria. Okay, so we're going to put this all together and try to look at an example problem of this. Okay, so the population of Maryland is approximately 6 million people. Okay, and let's just make a conjecture that maybe 31% of them are Democrats. Okay, don't know, completely making that up, could be true. Okay, so I have my setting. I have the size of my population is 6 million. The proportion of my population that are Democrats is 0.31. Great. Fantastic. All right. So I'm going to take a sample of this population. I'm going to grab 100 Marylanders at random. So I'm going to take a simple random sample of 100 Marylanders. And I want to know what is the distribution of those samples. Okay, so not every sample of 100 Marylanders is going to have the exact same value. But we're going to get some central tendency here, and they're going to be centered around a particular number, and that proportion is going to be centered, the proportion of the sample is going to be centered around a particular number, and I'm going to be able to calculate the standard deviation of that and all these good things. So the first question that I have is, do I meet the 10% condition? So 100 is clearly less than or equal to 0.1 times 6 million. So I have met the 10% condition. So my calculations of the standard deviation are going to be pretty good. Okay. If I take 0.31 times 100, that's 31, which is bigger than 10. If I take 1 minus 0.31, which is going to give me 6.9 or 0.69 times 100, that's 69. It's also greater than or equal to 10. So I'm going to be approximately normal. So I'm going to have a normal distribution with a mean. So the mean of this sample, the mean of this is going to actually be equal to p, which is going to be 0.31. Okay, and because I met the 10% condition, right, I'm going to have a standard deviation of those that's going to be equal to the square root of 0.31 times 0.69, which is p times 1 minus p, over the sample size, which is 100, right? So I'm going to pause here. I'm going to break out my calculator. So I'm going to take the square root, right, of 0.31 times 0.69 over 100, right, makes my standard deviation 0.4 or 0.046, right? So this is 0.046. Okay, so what does this mean? All right, so let's get a new blank screen here. We just said that the sample proportions are going to be approximately normal with a mean of 0.31 and a standard deviation of 0.046, right? So I have a normal curve, right, with a mean of 0.31 with a standard deviation of 0.046. Okay, so if you kind of think that through, that's pretty powerful, right? So like, let's say I want to know, let's say I took a sample, right, and I got a sample proportion of 40% of that sample proportion, right, were Democrats. Now, is that likely to happen? Could I likely have that sample? Well, the sample proportion should be distributed normal with a mean of 31 and a standard deviation of 0.046. So here's my mean of 0.31. Here's my my sample, which was 0.40. I want to know what's the probability of hitting a sample with 0.4 or higher given this information, right? So this should be a normal CDF case, right? Where my minimum is 0.4 with a mean of 0.31 with a standard deviation of 0.046. So let's go ahead and do that, right? I'm going to go second vars, there we go. Normal CDF, right? My minimum value here is going to be 0.41. My upper value is going to be some extreme value because I don't know. I'm going to need some approximation for infinity there. My mean is 0.31 with a standard deviation of 0.046. And I hit enter, and it tells me the probability of that is 1.4%, right? So the probability of being in this section is at 1.4 or 1.5. 1.48, let's call that 1.5, is like 0.015, right? 1.5%, which that's pretty unlikely, right? So it is, getting this sample is statistically significant because it is highly unlikely that I got that sample by chance. There's probably something weird about this sample. All right. So this is why we would use sampling distributions for proportions, right? Key here is it's categorical data. Are you a Democrat? Are you a Republican? Do you like blue? Do you like pink? Whatever. And then we use a proportion to manage the categorical data. All right, so there you go. Sampling distributions for proportions.